Good morning, student. This is your physics teacher. Today I am going to start the chapter viscosity. So let's start. Viscosity is a kind of frictional force, and it is actually generally acts in between the two layers of the liquids. So let us suppose that uh, there is a liquid and liquid is flowing in some direction. See over here, okay, and these liquids can be divided into number of layers parallel to each other. Then overall, here in the picture it has been shown that all are having the same velocity v, but actually it is not so. The layer which is near to the ground, or you can say the bottom portion, it remains at a lesser velocity, and the layer which is just above the ground, their velocity remains actually equal to 0. And the more we go away from the fixed surface, that is here from the ground, there we will find that the velocity is increasing continuously. So there we will find the velocity gradient. A velocity gradient means that there will be change in velocity with respect to distance between the two layers of the liquid. So the rate of change of velocity with the distance between the layers of the liquid is known as velocity gradient. And of course, if you put the unit of velocity and the displacement over here, you will find that velocity uh, unit is meter per second in SI system, and the displacement is only meter. So meter will cancel out, and overall you will get second inverse. Okay, now we are going to study about the friction force, how to measure this friction force. This friction force is better known as viscous drag, and it is directly proportional to the area of contact between the layers and the velocity gradients. So just here see that F is proportional to A, and F is also proportional to d by dx. See over here. So when we remove the variation sign, we will get the equal sign, and there will be a constant. That constant is known as coefficient of viscosity. Coefficient of viscosity, and the symbol over here, it is known as eta. Okay, so F is equal to minus eta A d by dx, or del v by del x, whatever. So you must be wondering that why minus sign is coming over here. So minus sign is coming just to show that it is opposite to the, it actually opposes the relative motion. That's why the minus sign is coming over here. Now see here, sometimes you will be asked to um, write the statement of the coefficient of viscosity. So when all the things like force, not force, sorry, area, del v by del x, if all the things except force and eta, if they are assumed to be unity, so see here, area has been assumed to be 1 meter square. So the area of contact between the two layer is 1 meter square, and the rate of change of velocity with displacement is 1 per second. Okay, so in that case we will find that eta is equal to F. So the statement of coefficient of viscosity is that it is numerically equal to the viscous drag, that is the force between the two layer, when area of contact is 1 meter square and velocity gradient is 1 per second. So you must be wondering that still you are not getting the feel of the viscous drag. So I would like to say that whenever something is uh, moving through a liquid, so the layer of the liquid, as we have assumed that the liquid can be divided into number of layers, the layer try to decelerate the motion of the moving body by applying some kind of force. So uh, when the two layers are in motion, so let us suppose that one layer is, the upper layer is moving very fast. Here it is v plus del v. Okay, v plus del v. Okay, suppose, and the lower layer is having velocity v. The distance between them is del x. Okay, so what happens actually, the layer which is moving with slower velocity. Due to this viscous force, their velocity increases, and the layer which is moving fast, here the upper layer is moving fast, the lower layer is moving slow. The upper layer which is moving fast, due to this viscous drag, their velocity decreases until and this continue until they reach a common velocity. So this is the viscous drag. Now the SI unit of coefficient of viscosity is Poiseuille, Poiseuille, like this we say, and it is a very big unit. We generally use the smaller unit, and it is this known as decapoise. Decapoise is the easiest unit of viscosity. And what is the dimension? If you put all the value, you will find that dimension of eta is m L inverse T inverse. Want to see? Let us try to find out the dimension of eta. So we know that force is equal to eta A dv by dx. Okay. Now force dimension is m L T to the power minus 2. Eta dimension we need to find out. The dimension of area is L square, and the dimension of velocity is L T inverse, and dimension of displacement is L. So L will cancel out. Now if you actually simplify it, you will find that the coefficient of eta is m L inverse T inverse. Thank you for watching the video, and I will say that share it along with your fellow students so that the video will reach to the mass level and others will get benefited too. Thank you. Thank you.